Hi guys, today we are going to talk about how to find the volume of triangular prisms and pyramids and cones. On Friday you should have been working on finding the volume of cylinders and rectangular prisms, but that was a review. There are quite a few of you that haven't done that yet. Please make sure you're getting that finished. This isn't going to make a lot of sense until you do that. So please make sure you take care of that. Also, as a reminder, remember Wednesday at 9:30 we have our live conference class. So please make sure you're there for that. It'll be good to hear from you guys and see you, yeah, just catch up a little bit. So hope you're doing well. This is the information you're going to need for today's lesson and today's learning that you'll be doing later. So we're going to talk today about triangular prisms, pyramids, and cones. And sometimes, especially triangular prisms and pyramids, we get mixed up. So we want to go over a little bit of how to do a triangular prism first. So to find the volume of a triangular prism, what you have to think about is, what does volume represent? So when we think about what volume is, I'm going to try to write on this and see if that'll work. When you think about what volume is, volume represents basically the base area that you've got down here. So this is a triangular prism, so the base is a triangle. Okay, it's named after its base. And basically what we're going to do is we're going to pull that that area, or that triangle, stretch it up along this side to make it three-dimensional. So essentially what you've got is layers and layers and layers and layers of that triangle. Okay, so if you can figure out what this base area is, we usually call it B for base area, then what you can do is you can stretch it and multiply it along the height of the shape to find the volume of it. So the volume of a prism is actually based on the formula volume is equal to big B times H, where big B stands for the base area and H stands for the height of the shape. Kind of the idea is between the bases. So there's your other base up top there. Okay, so what's the difference in those heights? Something that gets pretty confusing for some people is why you don't actually use this 5. Okay, and we'll talk a little bit about that today, but what you need to think about is when you're working on this, what information do you need to find the base area and what number represents the height? Okay, so I'd encourage you to think about those two things today as we're working. That's not working. Is it? Okay, there it is, great. So we're going to go ahead and do this problem together. Okay, so as soon as we recognize that it's a triangular prism, because it has two bases that are opposite of each other, we can use the formula volume is equal to the base area times the height. So what we need to do then is we need to find the base area. Okay, so we can do that kind of as a little aside, and this should be review, but thinking about how do you find the area of a triangle, okay, we know the area of a triangle is equal to the base of the triangle times the height of the triangle divided by 2. Now notice this B here is not a capital B. This isn't the base area. This is the actual base value. And on a triangle, we know the base and the height are always connected by the right angle. Okay, so you've got a height there and you've got a base there. So if I find the right angle in my triangle here, I know these are the two numbers that I'm going to need to use for my triangle area. Okay, so I can just do 4 times 3 divided by 2. Those 2's will cancel there. So I know I've got a base area of 6 feet squared. Now this is base area there. It's not base volume because it's just a flat. Basically what we've done is painted that triangle. We haven't done anything else yet. Okay, but what we know now is that the volume is equal to 6, because that's the base area, times the height of the shape, which in this case here is 5. That's what we have to stretch it along. So that means our volume is equal to 30 feet cubed. Okay. If some of you played around with some different IXL topics, you would have seen this last week. It's something that typically is more confusing to students than rectangular prism or even in cylinder. So I just kind of want you to be prepared for that. You'll see it a little bit today with the work that you're doing, but not a lot. There aren't that many shapes that are triangular prisms that we need to find the volume of. That it's not as critical of a piece to understand as cylinders and rectangular prisms. Okay, but the real key with all of this is, can you understand the difference then between a triangular prism and a pyramid? Oh, I wanted to show you one other thing real quick. This question over here is what it's going to look like when you see this on IXL today. So this question here, okay, is what you'll see on IXL. If you notice, the base of this shape isn't actually on the bottom. The base here is still this triangle, but it's on the side, okay? What you need to think about with this shape, okay, you wouldn't ever call this shape a rectangular prism. You wouldn't look at that and say, oh, it's a rectangular prism. No, you'd say it has a triangle in it, so it's got to be something triangular, okay? So that means then the base of the shape, right, whatever name the shape has, that's the base of it. So you need to be making sure you're finding that base area, okay? Because this is basically, there's your other triangle back there. You just can't see it because of how it's shaded, okay? If you have questions about what kind of shapes you're looking at, please make sure you ask, okay? So when you think about some differences, okay, between how do we know if it's a prism or a pyramid, okay, what we can kind of go through is, excuse me, as a pyramid has only one base. So there's no consistent shape throughout, versus a prism has two bases, and there is a consistent shape throughout. Now you'll notice it says Play-Doh here. So let me explain a little bit what I mean by that. So if a prism has two bases, that means this base here and this base here, okay, are the same shape, and they're connected by parallel lines, okay? So when you're a kid, you might have played with those things where you push the Play-Doh through the mold, and if you keep pushing the Play-Doh through, the same shape comes out, okay? Whether it's a star or a triangle or something like that. And so basically what you were doing is you were making prisms, okay? Because it was a consistent shape throughout, kind of like a loaf of bread, all right? Every piece of bread is the same shape, okay? But then we think about a pyramid, and a pyramid is different because a pyramid only has one base. So what that means there, if it's a square pyramid, there's not another square, okay, up here that it's connected to, okay? If it was, then it would be a rectangular prism, okay? But it's not, so it's just it's a pyramid instead, okay? If we think about this one here, okay, that's a triangular pyramid, all right? This is typically the most confused shape because there's lots of triangles, and so we think it's a triangular prism, but it only has one base. There's no other triangle that is in the same orientation that this matches above it, okay? If it did, it would be a prism, but because there isn't one, it's a pyramid, okay? So pyramid, one base, prism, two bases. Really, really important because you've got totally different formulas. A prism has a volume formula that's the base area times the height, because that base area gets stretched along the height of the shape, okay? But a pyramid doesn't have that same shape the whole way up, okay? It doesn't have the same area the whole way up the shape. So a pyramid, okay, is actually only a third of the base area times the height. So a pyramid's formula is a third of a prism's formula, okay? Which is kind of nice because it means you can just pretend like it's a prism and then divide it by 3, okay? But if you think about common mistakes, most people would forget to divide it by 3, okay? So that's what we're going to work on today. So the first question would be to look at this and to be able to recognize, is this a prism or is this a pyramid? So that key question is, how many bases are there? So when you look at this, okay, I can see, okay, this looks like a rectangle here as the base. There's not another rectangle that's above this, okay? So what I know then is that this is a pyramid, okay? As soon as I know it's a pyramid, what I should be doing is writing down the formula, 1/3 times the base area times the height, okay? Now we still have to treat this problem the same as we did the last one. We need to find the base area separately, but once we do, we can put that answer back into the formula and just multiply through, okay? So I know the base area in this case, looking at the shape, it's a rectangle, so it's just going to be length times width. So it's going to be 8 times 5, which is going to give me 40 miles square. So I can take that 40 miles square and I'm going to plunk it in for the base area. So that means then I've got 1/3 times 40 times 11, okay? So looking at what we're going to get there, all we're going to do is we're going to take 40 times 11. So 40 times 11 is 440, and then we're going to divide it by 3. And in this case, you are going to get some uglier answers, and that's okay. we're going to get 146 points, well, let's round it to 7 miles cubed. Okay, so 146.7 miles cubed. Okay, so we used the formula 1/3 base times height, base area times height, because this is a pyramid. Okay. If we look at this, okay, this isn't a pyramid and it's not a prism, this is a cone. But the interesting piece is that the cone's relationship to its larger three-dimensional object, which would be a cylinder. If we think about this, if we would take this circle and go straight up with it instead of curving in, now we have a cone. Or sorry, now we have a cylinder. And we know from Friday to find the area of a cylinder, it's going to be pi r squared h. This follows the same pattern as the prisms, because the cylinder's relationship to that shape, the cone's relationship to a cylinder is that it's a cylinder volume divided by 3. Okay, so it's basically a third of a cylinder, just like a pyramid is a third of a prism. Okay, so what we can do is we can treat this like a cylinder and then just divide it by 3. Okay, so it's really not any harder. So we're going to go pi, we need the radius. Looking at this, I don't have the radius, I have the diameter. So I need to cut that in half, so the radius is 2. So we've got pi 2 squared times 11 all over 3. Okay, now again, if I were you, I would do all of the number parts first and then multiply by pi to try to keep my answer a little bit neater. So when we do that multiplying, we're going to have 4 times 11, which is 44. So we're going to have 44 over 3 pi as our answer. And then if we go ahead and multiply that out, okay, we can take pi times 44 divided by 3, or 44 divided by 3 times pi. 44 pi divided by 3 is going to give us 46.1 feet cubed. Okay. So as you look at that, you really basically just did a cylinder. So again, if you didn't do your work from Friday, this is going to be a lot harder. So please make sure you do your work from Friday. Okay, watch the video from Friday. Take care of that because it's the same kind of operations here. Okay, all you're doing is dividing by 3. So cones and pyramids are a third of their larger shape. Okay, and prisms, I just want to make sure we recognize the difference between a prism and a pyramid. So your work today, okay, you need to, in 8th grade IXL, work on T8 up to a SMART score of about 65, and you're also going to work on T11 up to a SMART score of about 60. These are just using formulas. So the formulas are right here on the side, okay? So you're going to want to make sure you're looking at those, you're referring back to those, you're using these, okay? They're on Canvas, okay? They're in this video. They're on IXL for some of the questions. If you need some extra help, there are a couple links on the Canvas page, so make sure you read the whole Canvas page for today. But read the links, and then if you're still stuck, please send me an email and we'll schedule a Google Meet or a Canvas conference or something like that to help you out. Please remember Wednesday is live e-learning at 9:30. Please make sure you're there, and I look forward to seeing you guys there. So let me know if you have any questions. Take care.